Hello, in this video I'm going to solve the following problem for you. This is a problem in optimization and the title is Minimize the Fold. Let us read the problem together first. One corner of a strip of paper 8 centimeters wide is folded so that it lies along the opposite edge. See the following figure. Find the least possible length for the fold line. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do the calculations correctly, the answer that you will get at the end is 3 square root of 3 times a over 4 centimeters. Okay, now let us solve the problem together. Here, my goal is to minimize this fold line. In order to minimize a quantity, I need to be able to write this as a function of a variable so that I am able to use the notion of derivative to find the minimizer of my function. Okay, so let me call the length here of this fold line to be f. The way that I think about the problem is this. Let us say I want to tell you how to fold the paper by just giving you one single number. I hope that you agree with me. If I give you the distance from this point to this point, then you are done. For example, if I tell you this is 2 centimeters, then what you do, you take this part of the paper and then find that point 2 centimeters far away from this point, and then put this tip of the paper here and then press your paper to have this fold line. Okay, so that motivates me to be able to, this motivates me to express my quantity that I want to minimize based on this distance, which I call it x. So in other words, I have a function, I want to express my quantity f in terms of x, and then use the standard tricks of differentiations and putting it equal to 0 and etc. etc. Okay, so the strategy is now clear. I want to express f in terms of x. Okay, so let us put some information on the picture. So first of all, I want you to see that this length and that length are the same, because that is exactly this missing part of this paper. Okay, so it is very simple by construction to realize that if, let me call this length L, then this length is also L. And if, for example, I call this length from here to here M, then this length from here to here is also M. Okay, and now if I ask you what is this length, you will tell me that, okay, the total length is A because that's the width of my paper, and this part is L, so what is left for me here is A minus L. So, why these are important? Because if you see that this is a right angle triangle here, do you remember what was the goal? The goal was to express f in terms of x. F cannot be immediately expressed in terms of x, but immediately you can see that I can write f in terms of L and M using Pythagoras theorem. How? Very simple. So f squared, the hypotenuse squared, is equal to L squared plus M squared. So if I succeed to write L and M in terms of x, then this relation will finally express f in terms of x. Writing L in terms of x is extremely simple. Concentrate on this right angle triangle here, and again use the Pythagoras theorem, but this time the hypotenuse is L. So what I can write is that L squared is equal to x squared plus a minus L squared. And what I do, I expand the right-hand side, so it becomes x squared, the first one squared, 2 times the first one times the second one, and the second one squared. And now compare this L squared, oh, sorry, that is, I forgot to put the 2 here. So that is L squared, and that is L squared. They are cancelled. And I move 2a squared, 2al to the left. So this becomes 2al is equal to x squared plus a squared, and I am looking for L So L becomes x squared plus a squared over 2a. And that is good because I was able to express my L in terms of x. Okay. Now, in order to express m in terms of L, you can more or less do the same process, but I also realize that if I draw this vertical line here, okay, so this vertical line, of course, will be of length a, and my point is to demonstrate, to justify the similarity of these two right angles, triangles that you see here. Why they are similar? Because, for example, let me call this angle alpha and this angle beta and this angle gamma. So if I ask you what is alpha plus beta, you will answer me 90 degrees. Why? Because the whole angle is 180, and when I take this off, the sum of alpha and beta is 90 degrees. But on the other hand, because this is a right angle triangle, gamma plus beta is also 90 degrees. So this means that alpha is equal to gamma. Okay? Okay, so it means that this triangle and that triangle are two triangles with two equal angles. Alpha is equal to gamma, and this angle is 90, that angle is also 90. So these two triangles are similar. If the triangles are similar, the ratio of x over a will be equal to the ratio of L over m. So what can I write? I can write L over x. Oh, sorry. We can write L over x. Okay, so let me write exactly what I told you. So I can write L over m is equal to x over a. But now I am looking for m, so m becomes a over x times L. But of course, L is this quantity. I put it here. So this becomes a over x multiplied by x squared plus a squared over 2a. And after simplification, m becomes clear to be x squared plus a squared over 2x. Yes, so this will be m. Okay, and then we are done, because now instead of L and M, I put these quantities and then I find f squared. So f squared is equal to, instead of L squared, I put this one to power 2, which becomes x squared plus a squared to the power of 2 over 4a squared. And m squared becomes x squared plus a squared to the power of 2 over 4x squared. And if I take x squared plus a squared to power 2 over 4 out, the first one is 1 over a squared plus 1 over x squared. And if I take the common denominator, the numerator will give me another x squared plus a squared, so it becomes x squared plus a squared to the power of 3, and the denominator will be simply 4a squared x to the power of 2. Okay, but of course, be careful. You want to find f, so you have to take a square root of that. It makes the algebra a little bit more complicated. That is, of course, possible. If you're more comfortable, you can do that. But my trick that I want to use here, I multiply everything by 4a squared. So the left-hand side becomes 4a squared, f squared, and the right-hand side, this will be cancelled. So I would write 4a squared f squared is equal to x squared plus a squared to the power of 3 divided by x squared. Okay, so be careful. What I am saying, my goal is to minimize f, but so for minimizing f, I need a minimizer for the function f. But because the minimizer of f and f squared are the same, so it doesn't matter if I find the minimizer of f squared instead. On the other hand, for a squared is a constant, so the minimizer of this quantity and the minimizer of this quantity are the same. Minimizer of f squared is also the same as minimizer of f. So my point is that in order to find the minimizer, you can just find the minimizer of this function, which is simply this one. But for finding the minimum value after you found the minimizer, you have to be careful, so we will do it later. But hopefully I could convince you that in order to find the minimizer, I can work on this function. Okay, so if you don't mind, let me introduce a capital F here. So let me change my color. So I introduce capital F to be 4a squared f squared. Okay, and then I would write capital F of x is equal to x squared plus a squared to the power of 3 divided by x squared. And I want to find the absolute minimum value for the function. But of course, you know that we have limitations for the value of x. Okay, so the value of x is greater than 0, and it is at most equal to a. It cannot be larger than a. Yes. So, and that happens when I put this exactly here, then I will have this scenario. Okay, so this means that this is the case. Okay, when I calculate the limit of my function, of my capital function f, when x approaches to 0 from the right hand side, I will get plus infinity. And if I calculate f of a, I will get 2a squared to the power of 3 divided by a squared, which becomes 8a to the power of 4. Okay, so that is the values of my function, because this function is continuous here. But of course, it approaches to infinity if I go closer and closer to 0, and at a, I will have this one. Okay, so in order to find the maximum or minimum of the function, you know that you have to on an interval, you know that you have to calculate the value of the function at the endpoints, and also you need to find the derivative of the function and put it equal to 0. Okay, so let us just do the derivative. So the derivative, I use the quotient rule. So the derivative of the numerator becomes, so 3 goes down, it becomes x squared plus a squared to power 2, but I also have to multiply because of the chain rule by the derivative of that one, so which is 2x, and then I multiply it, it becomes 6x, x squared plus a squared to power 2. So this is the derivative of the numerator. I have to multiply it by the denominator itself, minus the derivative of the denominator, which is 2x. I have to multiply it by the numerator, and then divide it by the denominator to power 2. Okay, so what can I do now? I can factor 2x and x squared plus a squared to power 2. From the first one, a 3 is left, and from the second one, a 3x squared is left, and from the second one, minus x squared minus a squared, and everything divided by x to the power of 4. And now I simplify it a little bit, so this becomes this quantity to the power of 2, and then you have 2x squared minus a squared divided by x to the power of 3. So that is the simplified version of my derivative. Okay, so I moved what I needed from the previous page here. So let us put capital F, sorry, that was capital F prime. So let us put capital F prime equals to 0. Then it means that this quantity should be 0, because there is no way for this to be 0. So this means that 2x squared minus a squared is 0, and then from here you get two answers, plus or minus a over square root of 2. But of course the negative one is not acceptable, because if we go back, you see that x should be somewhere between 0 and a. So the negative sign is not acceptable, so the positive sign is acceptable. So a over a square root of 2. But of course, it is still not clear that this is the minimizer. What we have to do, we also have to calculate the value of the function at that final point. So I calculate f of a over a square root of 2. Okay, so and then what that is, if I go back to the previous page, so you see that this is my function. So I replace every x here with that quantity and see what the answer is. So this becomes equal to a squared over 2 plus another is squared to the power of 3, and then I have divided by this number to power 2, which is a squared over 2. And then when you calculate that, it becomes 3a squared over 2 to the power of 3, 27a to the power of 6 divided by 8, and then I have a squared over 2. So if you simplify everything, so it becomes 27 over 4, and then I have a to power 4. Okay, so these are the values that we get. 27, 4, a to the power of 4, a to the power of 4. And the next ones are these numbers. If you see, one of them is of course infinity, and the other one is 8, a to the power of 4. Okay, so if you want, I can just informally write plus infinity here. And what was that? We have 8a to the power of 4. So if I ask you which number is smaller among these three numbers, you immediately realize that this number is smaller. Okay, so what does this mean? This means that this quantity is the minimizer. It is the minimizer of the capital F, but as I told you before, it's also the minimizer for little f. So we realize that this is the minimizer of the function, so this means that this is the minimum of capital F. Okay, so now if you look at this relation here, what I can write, I can have f squared is equal to f over 4a squared. So this means that little f is square root of f over 2a. So this means that f minimum is equal to square root of f minimum divided by 2a. Okay, so what is f minimum? F minimum is this quantity. So this becomes square root of 27 over 4a to the power of 4 divided by 2a. So let us simplify that. Square root of 27 is 3, square root of 3, square root of 2, square root of 4 is 2, which will be multiplied by another 2 in the denominator. And then I will have a squared, then I will have a in the denominator. So as you see, it becomes 3 square root of 3 over 4, and then I have a. And of course the units is centimeters, so that is the minimum value for the fold line. Okay, so I hope that you enjoyed the video. Until the next video, be safe and goodbye. Thank you.